G'day everyone, and welcome again to the Race Academy webinar series. We are all the way now on to episode 28, and what a better way to do it than the most requested topic we've had to date, digital dentures. Whilst we're waiting again for the last few people to jump on board, I would like to look who we have on board with us today. We've got people from Australia. G'day New Zealand. The US, welcome to all of our US guests. India, welcome for everyone from India. We've got people coming in live from the IDS show, the International Dental Show in Germany. Welcome to everyone over in Germany. I hope the show's going well. Do come back and fill us in with all the exciting new things happening over at the International Dental Show in Germany. We've got our guests and friends from Malaysia, again, some friends from Singapore, and I'd like to make special mention for our people who have joined us today from Dentsply. Welcome everyone from Dentsply. We love you guys, and the new products that you've brought into our lab and launched through Asia Pacific has been spectacular. We do appreciate that you guys have joined us, and we look forward to promoting these products today. Before we do go live, I ask you all to hold your questions. There is a section you can ask the questions at the bottom, but I'll be monitoring those and asking our guest speaker for his answers to those at the end of the lecture or webinar today. I do have mentioned the Australian Dental Exhibition coming up 30th of March and 1st of April. Pretty exciting times. So come on down and see the race team down there. Brad will be leading the charge there with his crew. I'd like to make mention that we are finalists for 2 awards this year. The Innovation Award, compliments of our digital denture product, which you'll be learning more about today, and also the Educational Initiative with the Race Academy, which you are on and using today. So come and see us down at ADX, stand 566. Come and mention us, and we look forward to seeing you all down there. But I'd like to introduce today our guest speaker, Ian McFarlane, who is a wealth of knowledge in this arena. He's the technology and operations consultant for Race, currently over in Monterey, California. Ian, g'day. How are you today?
I'm doing good, Matt. How are you doing?
I'm well. It's a bit chilled here. In comparison, I believe you've got some cyclones going on over there. Can you give us a bit of a rundown? Your hair doesn't look to be blowing around too much currently. Fill us in.
Yeah, no, I'm safely inside right now. So one, I don't have any hair to blow around, and two, even if I did, it wouldn't be blowing anyway. So we're all good, and it looks like we're in between storms. So I think we're going to be smooth sailing for this presentation at least. I can't guarantee what it'll be like in 2 hours from now, but we're good now. So that's what counts.
Oh, that's great, mate. Whereabouts are you in California?
So Monterey, California, it's about 80 miles south of San Francisco. If there's any golfers in the audience, we're basically where Pebble Beach is, where I could probably throw a rock over to Pebble Beach right now, a little bit north of Big Sur. So if we've got any people who love driving and driving coastal roads, we're on some of the best coastal roads in the world, and we're a good maybe 5-hour drive down up from Los Angeles too. So we're kind of smack dab in the middle of the California coastline. Good weather usually, just not lately.
Oh, mate, well, I hope it all blows over, so to speak, and we're looking forward to getting your presentation today. Ian, like I said, this is the most exciting product globally at the moment. We've got questions coming in. It's our fastest, most prolific product that we've launched ever to date, and really we haven't seen a product take the industry by storm since the CNC milling technology for crown and bridge and customize abutments for the implant department. I believe, look, we've got a whole bunch of things you'll be going through today, Ian, but obviously getting a better product and a more aesthetic and fitting product, but decreasing chair time. Is that what you think would be the most advantageous concept of the digital denture?
Yeah, it generally is, but it really, to answer that, it kind of depends on who you're talking to. If you're talking to a clinician, obviously decreasing the number of appointments, decreasing chair time, and just speeding up the overall patient is incredible, or the experience is incredibly important. But for the patient as well, obviously less visits into the dentist. But if you think about what a digital denture is and the concept of digital records and the permanence of these records, if a patient ever loses a denture or they're going on vacation and they want to have a spare set, I mean, we can just manufacture a second one exactly the same way this was. Now, having said that, it's not the only advantage. Digital dentures have actually gone through a few evolutions now, and we're at a point where the materials, and we'll be talking about the Dentsply, the lucitone digital print material that we're working with, the materials are actually stronger than traditional dentures. And that wasn't the case for quite some time, but we've actually sort of just wholesale beat the analog process now in terms of appointments and appointment times and in the material strength and the accuracy of the process. I mean, there's just this entire ecosystem that ultimately leads to a much better experience for the doctor and the patient. So yeah, you hit it, but you hit one of about 10 really good good things. And that's why it's sort of taking the industry by storm.
Yeah, right. And you've been, with your 20 years in startups for digital denture production and also other technologies in the corporate and private sectors. Look, I won't hold you up. No doubt you can fill us in a little bit about where your background is to start us off, Ian. But let's jump straight in, mate. Digital dentures, all yours.
Yeah, sure. I'll give you a quick background of mine. So I was in the dental industry for about 15 years and on the private side, and I worked in clinical and laboratory settings. I actually owned a couple of dental labs and had partnered with a couple of clinicians on some ventures. But I moved over to the corporate side, and I worked at Ivoclar Vivadent for 3.5 years as a technical consultant and a product developer over there. About 3 years in, I had noticed a Silicon Valley-based tech company that was just starting to ease into the dental space with their 3D printers. That was Carbon 3D, and I was fascinated by what they were doing. I was fascinated by the direction of printing in the dental industry at that time, and called them up and wanted to know if they had any job openings at that time. And they said, well, we've got one person in dental right now, and he's building our dental business for us as we speak. So he's probably the person you want to talk to. And I did talk to him. And as that vertical within Carbon was growing, I was one of the first people who went over there, and I started off as an applications engineer at Carbon, and then moved into the head of dental product at Carbon. Now, the reason I kind of dwell on that a little bit is the biggest launch or the biggest product that we had going at Carbon 3.5 years ago, almost 4 years ago, was the lucitone digital dental or digital denture resin that was released. So a big part of my day-to-day was actually integrating real legitimate digital dentures into the US market and then into the European market as well. So I saw firsthand the transition from early digital dentures from a milling side and from like Gen 1 resins into the real full-fledged solution that we have today. After Carbon, I went to Miami. I love tech startups. That's a robotics company. They've got a surgical robot that is FDA cleared in the US and has got 10,000 implants placed over the last several years. As product manager over there for quite some time, and then got a call from the from the Aussies, from Matt, your brother Brad, and Andrew, and said, "Hey, we're looking for somebody with a really crazy varied background to help us integrate a lot of things, and digital dentures is one of them." And I said, well, that sounds really cool, and I'm definitely in, and let me head on over there and start helping you guys out. And so that's kind of the short route of how I ended up at Race Dental, and that's how I'm consulting, and those are the types of things that I'm consulting on. But again, it's a very wide-ranging background of tech and materials and integrative concepts and organizational concepts that I've been brought on to Race to handle. So I see you nodding, Matt, so I'll just move right into the actual presentation here. So to the question, in this, digital dentures have been around for about 5 years, but it's always an interesting question that gets asked from doctors who are sort of new to this is what exactly is a digital denture? And a lot of times when we think of a digital denture, we think of an entire digital workflow from digital record capture. I get asked a lot of questions about, can you scan patient's existing gum tissue, for instance. Where do we actually pick the digital workflow up is a question that I get a lot. Digital dentures actually refers specifically to the manufacturing process around the digital denture. It's not necessarily a reference to record capture, or more specifically, where record capture actually occurs. It's really a reference to what's being done once records have been digitized and how this denture is actually manufactured. And so we'll kind of go into a little bit of the evolution of digital dentures themselves from a manufacturing perspective. Obviously, everybody knows that traditional dentures have been around forever. I mean, they've been around from the days of vulcanite and pre-vulcanite, and we've gone through many iterations on the analog side of the house, but we haven't really penetrated the denture market from the digital perspective until only very recently. And Matt, you had mentioned CAD/CAM and milling, and milling Emacs and crown and bridge type stuff. Digital has been in the dental industry for quite some time, but from a denture perspective, it's pretty brand new. I mean, it's sort of broken new ground in the US, and it's broken new ground in Europe. It's relatively a new introduction to Australia. And the first iterations of that were obviously from a milling perspective, because milling was really the first digital manufacturing process that could actually produce decent materials that could go into patients' mouths as an end use product. I mean, we've had printed models in the industry for a little while, and we've had other printed materials, but not as an actual end use product. It's only been within the last 3 or 4 years that we've really had printers that are capable of printing well enough a prosthesis or an appliance that's going to be in the oral environment for a long period of time during the day. And it's only been within the last 3 years that we've actually had what I would consider to be a legitimate denture material that can be printed. So we're seeing that this rapid increase in technology and materials, and it's all kind of coming to a head right now. The Gen 1 materials were sort of like a proof of concept from the printers, in the sense that we showed that you could print a denture, and it had all the accuracy of a printed denture, and it had everything that you would expect from a denture. But the early materials that came out, they weren't very durable, they weren't very aesthetic, and frankly, they didn't make a good denture. They sort of showed that it could be done, but they really just didn't make a good denture that you would want to put into a patient's mouth. It wasn't until the partnership with Carbon 3D, the printer company, and Dentsply, the materials company, with the lucitone digital print, that an actual high impact denture base and denture tooth material was printable and introducible to the broader dental market. So where we are today is we are printing dentures. That is absolutely the best way to manufacture a denture. We'll kind of talk about that briefly. And we are printing specifically lucitone digital print material, because until another material comes onto the market, that is, and I can tell you this from years of experience in the US and Europe, that is the premium material on the market right now. It stands head and shoulders above any other printable material out there. And it's the one that I would go with anywhere in the world, any time of day, always. So when we're talking about the digital process in general, and this goes back to the question of what exactly is a digital denture, really we're talking about digitization of records at some point in the process. And that can exist really anywhere. If we're talking about a new patient who doesn't have an existing denture of any kind, we don't have to go digital right away in the process. We can keep things as analog or as traditional as the doctor wants. We can keep them as analog or traditional as the laboratory wants. We can take traditional impressions if that's what's desired. We can go through the process of fabricating bite blocks. We can make custom trays. Every process that you know right now today can be done and carried out in its current form, and you can keep the same number of appointments that you've always been doing. And there's really nothing wrong with that, except for you're keeping the same number of appointments. And two, the more steps or more analog steps that you introduce into the process, the more points you introduce where variability can occur, or you can get some kind of a lack of the ultimate accuracy that you can achieve by digitizing the process earlier. I know that that's kind of a roundabout way of saying the more you digitize and the earlier you digitize it, the better it is. But there are a number of doctors out there who sort of stick to a hybrid approach of analog and digital. Now, in the digital world, there's something very unique that you can do as well, and that's make use or take advantage of an existing denture that the patient might have in a process known as a reference or a copy denture. So when we get into the reference or copy denture technique side of things, this is where we're really talking about dropping a significant number of appointments out of the equation, down to 2 appointments potentially. I mean, you can literally go from a patient comes in, presents with an existing denture that maybe they need, maybe it's not fitting quite as well as it used to. Maybe they want some slight modifications to it. Maybe it doesn't fit as well as it used to, but it's great in terms of appearance and aesthetics, and they don't want to change anything about it. They just want the thing to fit better. That denture can serve as basically the best custom tray that you've ever seen. And you can simply fill that denture up with impression material. You can take a wash impression of it, use that as the impression itself. You can scan that denture with the impression in it, and then digitize that physical object and turn it into what would either be a reference or a copy denture. So in this case here, what you're looking at is the digitization of an existing denture with a new impression in it. If this were what we called a copy denture, just a straight copy of what we've got with the addition of that new impression, all we would do in this case is just smooth out those areas where you see the impression material kind of ending in the real denture beginning, and not make any other changes to it. And we basically print out a direct copy of the denture that the patient has right now. It's just got a much better fit because it's got a brand new impression in it. If this were a reference denture, what we would do is we would take this same exact scan and we would use the existing denture as a template that we could modify. Let's say the patient likes the teeth, but they want some kind of inclination on the teeth. They want some sort of change, maybe an aesthetic change to it. They'd like a little bit more pronounced gingival characteristics or something like that. We can go ahead and make those modifications, keeping, of course, the accuracy of the impression and keeping the overall dimensions of it. So to kind of walk through that again, and I'm going backwards now to the brand new case where you're going to most likely end up with the most amount of appointments, is if it is a brand new case, you can take an impression, you can scan that impression, and the lab can do anything from create a wax rim or a secondary impression tray to continue that same number of appointments that you would normally do, or they can start the process of digitizing and working ahead and creating like a temporary denture out of it. We'll go into that in a little bit deeper. But at this point, what I hope you're seeing is that depending on the type of data that we're inputting into the system, and depending on how we want to handle this, we can start dropping out a number of appointments pretty quickly. Once the information has been digitized, whether this is the scan of a model that's been poured up, or the scan of an existing denture with impression material, or the scan of a preliminary impression, or the scan of a secondary impression or a final impression, we end up with a model that we can then identify some key landmarks, and that helps the CAD software identify where to place the teeth initially across the arch. Again, if we're not doing a direct copy of that denture, if we're going to be doing some kind of a design to that denture. And then we go ahead and we identify where we want the borders of that base to be. We simply just draw those in by point and clicking. We import the teeth in the simplest of cases where we're talking about a full over full class 1 bite. We simply import a library of teeth, an upper and a lower arch of teeth. They import in occlusion. We make the modifications that we want to make in terms of width and how we want things maybe angled or shifted or changed. There's not a lot that we have to really do here in this situation. And we move it into the finalization of the design, and that's where it takes that outline of the denture base that we've made, and it goes ahead and it creates the denture base to whatever thickness we desire, and we can go ahead and make some secondary modifications to the denture base itself. We could also make modifications to the teeth. This is all a very simple, quick, and easy process that can be followed. And what it means is that once we've got a design that we like and a design that's accepted by the patient, this is also a permanent record that we can always pull back up and simply reprint. We just remanufacture any extra dentures that we want out of that. So again, if you got a patient who's going out on vacation or something like that, or a patient who's misplaced the denture that they have and really like, you don't actually have to do anything. You don't even have to see the patient, actually. You can literally just call Race up and say, hey, I need a replacement for the denture that this patient has. And we just go ahead and remanufacture the thing. So where you save appointments, obviously, in the early stages, you save a massive number of appointments at any point after that to include 2 or 3 years down the road, or whenever you want to do a reline, or you want to do some kind of a refit of the denture to the patient. All you actually have to do is take that existing denture, again, put a wash impression material in it, scan it, that data gets uploaded into this file that you're looking at right here. And the intaglio surface of the denture is changed according to whatever tissue changes has happened. And then we send that denture. So there's no new back and forth once a record has been created for that patient, once we have a permanent record for that patient. Those dentures are printed up. The bases are printed. Here you're looking at the lucitone digital print bases. You're looking at the lucitone digital print teeth. Both of them are printed on a carbon printer. They are assembled using basically it's the same material or the same resin that the bases and the teeth are actually printed out of. That what you see up there in the upper right-hand corner, that's a brush putting in what's called the Fuse 3 material. To give you an idea of what that is, it's basically the base resin that the denture was manufactured out of. And what that does is it allows you to, after curing of these two dissimilar appearing parts, the teeth and the base, it gives you one single homogeneous part that is lucitone digital print from incisal edge all the way down to intaglio surface of base. The colors are different. They look dissimilar because it's teeth and base, but the chemical makeup of that entire denture is the same thing all the way through. And if you look down in that lower left-hand corner, what you see are different types of dentures put into an Instron machine and broken. And the one on the left is a lucitone digital print denture. And you can see the break did not occur at the junction between the teeth and the base material. And that's because from a material science standpoint, there is no tooth and base separate layer. It's all one layer once this thing has been finally cured. So the strength of the denture is phenomenal, even if the material itself wasn't stronger, and we'll get into that in just a little bit, but even if the material wasn't stronger, the denture is still stronger because it is one homogeneous part all the way through. Now, when it comes to what is actually being fabricated, you have several options on what you want to fabricate first in terms of a try-in denture. You can use the try-in denture material and fabricate a monolithic monochromatic try-in denture that works basically as a functional try-in. This is obviously a lot better than a wax try-in. The patient can walk around with this. They can chew with it, they can eat with it. It's a lucitone digital print denture. It's just in try-in material. And if there are any changes that you need made to it, you can simply indicate those on the denture itself. You can mark it up, you can grind on it, you can write little notes on it. You can do whatever you want with that denture and send it back. And Race can just go ahead and incorporate those changes into the final denture. Now, one of the things that we've noticed and that we've seen with the digital denture process in general is that a lot of people, rather than getting a try-in denture and characterizing it with some wax tissue or some pink wax on it or making it look more like a real denture, after the back and forth of the first few cases is done, a lot of doctors become very confident in just receiving the final denture as the try-in denture, because one of the things about the digital process is there's not a lot of error introduced into it. You're not packing material, you're not moving materials around. It doesn't go through a lot of stages to get to its final dimension and final shape. And most people start to realize, well, could you just send me the final denture? And if it works out, great, we'll just use that as the final denture and send the patient on their way. where normally a try-in step would have been accomplished. And if there are any minor changes to it, we'll just indicate it. We can allow you to take that final denture and just the patient can just keep wearing that. We make the changes necessary, and then we send another denture out that incorporates whatever changes were indicated on this denture. But the point is, and this again goes back to that concept of the digital records and the permanence of those, is that the entirety of your workflow is kind of upended and shortened simply by the fact that we're not actually physically transferring data back and forth anymore. We've got one master record that exists digitally, and any changes we want to make to it, we can just keep pumping out new dentures based off of that. So I hope that's clear. If not, please ask questions at the end about that. So in talking about, I kind of alluded to the fact that, well, not alluded, I think I said it pretty blatantly. A lot of doctors, after a few appointments or a few cases, just start asking for the final denture. The main reasons for that is that the digital workflow is so much more accurate than an analog workflow. And the earlier you pick up the records and you digitize them, the more accurate the workflow becomes. If you take an impression of the patient, or you take the denture and you use impression material and take that impression, doing it that way, and digitize that immediately, there's no chance that that impression can distort over the next couple of weeks. There's nothing getting poured in there that can be dropped or shaved off or distorted in any way. Once these things are digitized, the dimensional accuracy of them is basically set in, I was about to say set in stone, but it's not set in stone. It's the opposite of being set in stone. It's set in the digital world at that point. And you don't have any accuracy loss at follow-on steps throughout the process. In fact, everything that comes out at the end is maintaining the same core accuracy that was input in the beginning. So again, we're looking at a new denture setup there on the left, and we're talking about pouring up impressions and making wax rims. We're introducing a little bit of inaccuracy at every one of those stages simply by the nature of the materials that we're using. Whereas if we digitize from an impression early on, we're maintaining that digital accuracy right from the get-go. One of the things that studies have started to show about accuracy and the digital benefits is that it's not simply a function of digital being more accurate than analog in the broad sense. It's been shown out that the manufacturing process has varying degrees of accuracy as well. 3D printed dentures have consistently been shown to be more accurate than milled dentures. A lot of that has to do with the simple fact that a mill, regardless of how good it is limited at a max to 5 axes. So when you mill a denture out, and especially if you're milling complicated geometries out of that denture, there's a possibility that you'll have to either block out an excessive amount of area to get around certain spots, or the mill itself may not be able to reach certain areas. So you've got limitations of what a mill can do when it comes to manufacturing a digital dental or a digital denture. And the other limitation that mills generally have is, of course, burr size. The tool itself that's being used by that mill, it becomes a limiting factor in terms of accuracy. It becomes a limiting factor in terms of detail that's captured. And that forces a technician at some point to have to go in manually, or in an analog world, make adjustments to that denture. But the second you start doing that, you do run the risk of degrading the amount of accuracy that you actually started with. A printer, additive manufacturing, simply takes the file, the digital file, and it just builds up that file without any type of limitation of tool paths or size of tools or anything like that. So even within the digital process, manufacturing process matters. And then when you get into printing, the type of printer you use actually matters as well. There's varying degrees from printer to printer to printer. Not all printers are created equal. Race has gone with, and I always point this out to people, that they have gone with the gold standard of printers, the most accurate and most expensive printer that you can get on the market. They put in an incredible investment into their digital denture offering. And they chose a printer that is widely used throughout the commercial industries because of its accuracy, because of its robustness, and because of its repeatability. The carbon printer specifically prints in a way that is unique in the 3D printing world. It uses what's called a dead zone that allows it to create a part that is essentially layerless. We don't really have time to go into the technical details of what that means, but we'll talk about briefly the isotropic properties of a carbon printed part versus a part printed on any other UV printer out there. And this counts, and it counts big in the denture world, because when you do not have an isotropic part, meaning that whatever direction you cut it, you're going to see the exact same material and the same orientations without the layering effect that you'll see in traditional printing. Whenever you have a non-isotropic part, you have noticeable layers that have been stacked on top of each other one after another and actually show an effect called layering. And that layering can lead to delamination over time. And if you think about the environment that a denture is in, delamination between layers can allow bacteria and moisture and a lot of other things to seep into that denture, which will ultimately cause it to fail prematurely. One of the interesting things when we talk about material strength is there's an inherent material strength to the material itself, but that material strength can only be achieved in a manufacturing process that does not do anything to degrade the material itself. So a lucitone digital print denture printed on a carbon is actually going to be more accurate in terms of fit and more durable over its life than the same material printed in a different printer. So as you can see, we're sort of funneling down from least accurate way to do something to the most accurate way from a manufacturing perspective. Just to give you an idea, the people who trust carbon printers in their businesses, Osprey, Ford, Specialized Physique, Riddell, Rawlings, NASA has parts that they've printed on carbon printers that have gone into space. In terms of legitimacy of manufacturing equipment, there is nothing more legitimate than the equipment that Race is printing these parts on. And that counts for a lot because it means a lot in terms of the long-term durability of the part. And it gets even more interesting when it comes to accuracy, because say you're printing the same exact part on the same exact printer, the material you're using makes a difference as well. That material across the bottom where you see a lot of green within 100 microns, that's the lucitone digital print material. The material you see above it, that's a different denture resin that's made by Denture. It's printed on the same exact printer, handled the same exact way, and they're the same exact parts, and the material itself is not as accurate because the amount of science and research that went into the curing and the printing and everything that goes into taking a liquid resin and turning it into a hardened material was not as sophisticated in those Gen 1 materials as it is in the Gen 2 material that Dentsply has put onto the market. So if you look at it, think of it this way: digital, more accurate than analog; printing, more accurate than milling; printing on a carbon, more accurate than printing on anything else; printing specifically Dentsply lucitone digital print material on a carbon, more accurate than any other way you can do anything. So the point that I'm making here, and I'm making this with a lot of words, is that the product that Race is creating has got everything that you need to get the most accurate, which means the best fit, the most comfort for the patient that you can possibly get today. There's nothing better on the market right now. The material itself, lucitone digital print material, comes in a base resin, and it comes in a tooth resin, well, two teeth resin actually. And there's 16 A through D shades plus 2 bleach shades on the teeth for the premium. And we'll talk about that in just a second. And then for the value, that's the resin that's used for the tri-and dentures. There's 6 shades on that. I want to talk real quickly about the flexural strength and the flexural modulus of this material, because this was the big thing that really changed and brought digital dentures into kind of the light that it's in now. Is that you can see the lucitone digital print material compared to lucitone 199, which was kind of a reference denture material for quite some time, and the lucitone HIPAA material. The lucitone digital print right out of the printer, right out of the cure box, just straight finished and made into a denture is equally as strong as any high impact denture material out on the market today. But one of the interesting things that Dentsply found out when they created this UV curing resin was that when this material hits body temperature, an interesting thing happens and the work of fracture on the material actually doubles. So this material is twice as strong in the mouth as it is out of the mouth, and out of the mouth it's as strong as any denture material, whether it be a traditional or a digital denture material on the market. So it's really, not only are you getting the best of accuracy and you're getting a highly aesthetic denture material, you're actually getting the strongest material on the market as well. The types of materials that are offered, you have the value material, which comes in 6 shades. It's got 3 years of durability on it. And you've got the premium material. This is the material that Race uses in their dentures. This has got 7 to 10 year durability. It's got 18 shades, 16 A through D, 2 bleach shades. But here's the interesting thing, that over the life of a denture, 7 to 10 years, that's probably gone through a lot of changes in the tissue. That's probably gone through a lot of needs for relines. You actually don't need to keep a denture in a patient's mouth for 10 years. The big thing about the digital denture process is once you have that initial denture created, a reline is almost an unnecessary thing. It's almost better to simply take a wash impression when you're ready to do the reline, send that data to the lab, allow them to integrate that into the existing file, and then just manufacture a brand new denture. So again, there's a lot of time saving up front depending on how the patient presents, whether they're presenting with an existing denture or whether they're presenting with a new denture. There's time savings up there. But once that denture is created, over the life of this denture, the amount of appointments that are saved it's incredible. You don't actually have to remake a denture every time something is lost or something needs to be completely redone. You can repair these dentures. You can repair them just the same way you would a traditional denture. And if a patient comes in like on a Friday afternoon or something, and it's got a chip in the denture and they need it repaired temporarily, it's fine. You can certainly do the repair. The easiest thing to do though is simply call the lab up and just say, hey, a tooth broke. Can you just remanufacture the denture? And that's what will happen. So I hope what you're getting out of this is that there's a serious time savings across the entirety of the life of these dentures. The applications that this material can be used for is obviously full dentures, full over natural existing teeth. That's kind of the easy one and the first one that came out on the market. But you can use these as metal-free partials. People are making partial designs out of these dentures. You can actually put clasps in them. It's not a very complicated process to simply design the denture with a cutout where you're going to place the clasp and then cure the material over it. Because again, when you cure the lucitone material to lucitone material, what you end up with in the end is just one homogeneous part. It's lucitone material all the way through. So I think sorry, I went through that super fast, Matt. I've got a clock staring at me, so I hope we've got time for some questions.
Yeah, sure, mate. All right, firstly, thank you. To simplify what has really been a long road to getting these products as good as they are. I know that they've been highly sought after, and to simplify it like you do, like you have, is appreciated. I'd like to take this opportunity, Ian, to thank you firstly for consulting on behalf of Race and being integral in the rollout of this product across Asia Pacific with our capabilities and our printing and milling techniques. So thank you. I'm going to jump straight into questions. I know that we've got a couple here, so I will jump on. I don't have a lot of time, so I'll limit it to these first few. If you mark changes on a try-in with a marker, can you scan and send a file instead of sending the try-in back? And if so, do I need a color scanner to do so?
Absolutely, you can scan it and send it back, and no, you don't need a color scanner to do so, because what it's going to do, even a non-color scanner is going to pick up that marking on there. What the lab needs is the ability to see that in real view. That's really it. Your scanner should pick up any markings that you've placed on there. Now, if I'm missing a scanner that does not somehow pick that up, you can always just scratch something in. I've seen what people will do sometimes is they'll mark the lines that they want to convey, and then with a handpiece or a scalpel, they'll just scratch the line in there on top of it. I would say the very first time you scan it and you send it, and we say no, we can't see the mark, then you know from then on. But as far as I know, just about every scanner I've ever seen these things come off of, yes, you can pick those lines up, you can see them, totally fine, no issue. If not, just scratch them in with the handpiece.
Oh, there you go. That's good to know. Thinned out, these lucitone printed dentures are quite flexible. Does this mean we no longer need metal partial clasps?
So that's the question of the year, I would say. And it's really a question that comes down to what type of bite are we looking at from the patient. It's really like a case-by-case call. The answer is yes and no. Yes, you can make these with clasps, and no, you don't need to make them with clasps unless you think, based off of what the patient is presenting with, you probably should put a metal clasp in there. One of the interesting things about designing a digital denture is that when you're designing a digital partial, you can design varying thicknesses across that partial. So you can thin it out in some areas in order to gain flexibility. You can thicken it out in other areas in order to gain rigidity. So it's kind of one of those. I mean, I'm not sort of pushing back on this. I'm just kind of saying it's a case by case thing. But the beauty of it is you can work around any type of case that comes in based on either modulating the thickness or modifying the thickness around there, or just going ahead and saying, hey, we're going to be extra cautious here, and we're going to put a metal clasp in it. So yes and no is the answer to your question. How's that?
Yeah, okay. No, it makes a lot of sense. If I could interject there, Ian, in the lab when we've been making these partials, we do have a lot of them that are made without metal clasp, and a lot of them are required. And I've noticed in the aesthetic zone, when you have a desirable undercut sub-survey line on a tooth, and the survey line is in the body third of the tooth, a lot of the time that flexible clasp will be engaging too much of the tooth, and you'll hide a lot of the natural tooth underneath. So in those instances, the techs here will request to bend a wire and in place it to try and hide that a little bit. Otherwise, that flexible component ends up eating a lot of the cervical half of the aesthetics in that retentive tooth. So I hope that makes a bit of sense.
I'm nodding my head. Yeah.
Yeah. Okay. Well, thanks, mate. I wasn't sure if that cyclone had hit or not yet, mate. But
no.
And you've answered this next question. It's can these dentures be relined? And I'm sure that it's a question that's not silly in any way, shape, or form. And I know you're going to let us know your detail. But obviously, sending it back, you mentioned to have a new denture made makes a lot of sense and is the best way forward. But for those clinicians that the old school clinicians that haven't quite adopted yesterday's intraoral scanning or impression technology yet, it probably may be required. So could you answer the question still?
Yeah, you absolutely can reline these dentures, and you can repair them as well. So they do handle like a traditional denture. And I can, if there's anybody on the call now who wants to know which specific materials Dentsply recommends, we can get that out to you. But relining and repairing the dentures in a traditional way is totally doable. And I totally get that some people are just more comfortable doing it that way. But the short answer is yes, absolutely, you can do it that way. We still recommend that if you reline it, just spray scan it and send that, and then within a few days you can have a non-reline but currently fitting denture. But if you want to reline, you can. Okay,
and what about the occlusal rest that a metal partial would normally provide? How do they tackle that?
I'm not sure I understand the question.
I'll just read the question straight out. Can you add occlusal rests to the resin base to avoid vertical pressure movements, which is one of the main functions of a chrome framework?
I've never seen that done. Now, that's a really interesting question, because if you're adding it by modifying the design of the denture and then just essentially absorbing it within the denture by doing the same way you would do a clasp, the answer would be yes. You would use the tooth colored resin as sort of the bonding, the overlay of it. But I've never seen anybody do an occlusal rest in a denture. I've seen clasps in a denture.
Well, if I could interject there again, look, that technique for chromes, it really is reliant on a tooth-borne solution, where I guess when we're printing these dentures, we're relying more of a soft tissue borne concept. So I guess it wouldn't really be utilized. You wouldn't be using a framework, the denture, to be engaging on an occlusal rest in that way. So I appreciate you getting back to us here. I'm just going to move on here, Ian. The questions are pouring in now. I sent a digital scan for upper partial acrylic denture. It didn't fit well, even though the digital scan was sound. What could be the reason for that? And before you do ask that, it is a big question, saying that there's a lot of moving parts with that. It could be an inaccurate scan, depending on what sort of scanner it is. If it's not one of the leading scanners like the Prime, the Meta, or the 3Shape, that could be an issue as well. But maybe you could throw a bit of light on that subject, Ian.
My first thought on something like that would be the design itself, because if the scan is sound, meaning you've got something accurate to work off of, the printed and finished prosthesis coming out of that is going to be pretty much an exact copy of whatever the design was. I would actually look at the design. I'd be curious to know more about this specific case, but my culprit just off the top of my head would be in the design itself. Something happened in the design. There's always a possibility that in the processing of the denture, distortion would have happened if it was processed incorrectly, but that's design is where I'd be looking first, to be honest, and then I'd look to see. I'd look to see maybe at other variables, if it's a partial, if some area was too thin, which led to some kind of a processing error. But in general, what we're talking about, the accuracy of the scan and the accuracy of the part relative to whatever was designed is going to be dead on. Like, you should get out of the manufacturing equipment exactly what you designed. If you don't, then you'd have to start looking at a processing error somewhere in there, or a design area. I'd love to know more about that case.
Look, it would be fantastic, and it is an anonymous attendee, so not one of our clients by look of it. I'd love to get that file in and print for them and show you that these actually fit far better than any traditional denture ever could or would, with shrinkage that we've eliminated these days. So if that person could get in touch with us, send it through here and let us print it with our technology, I'd love to see the improvements in fit that we could provide. There's people asking questions about the size of denture teeth. Can they be made larger or smaller? Of course, that's a design system. You can make it as large or as small as you wish. You've got to get out of the traditional manufacturing tooth card concept, and you can make the teeth as large as small. The occlusal table as big or as small as you like. So design wise, we can do far more than we ever could with today or with yesterday's traditional manufacture technique, where we're reliant on a tooth being removed from a card. So absolutely. Unfortunately, Ian, before I throw you under the bus, I will let the team know that we've run out of time for the rest of these questions. It does go to show you how excited people are with this product, and how amazing what you're doing here and what you've launched for us has become, Ian. So I'm going to ask you one last thing, as I do with everyone. I want to throw them under the bus and say, can you leave us with one last point as to why you believe digital dentures are the future?
Just one point.
Yeah.
Okay, so honestly, for me, if I could pick one thing, it's permanence of record. The materials are there. The materials are solid. They're 100% as good or better than anything that's existed within the industry. Yes, we cut down on patient visits, but the peace of mind for the patient to know that if anything happens to this denture at any point, it's literally a phone call into the office. I just need another denture made. And from the office, it's a phone call into RACE, into the lab, and it's remanufactured. At the end of the day, it's a patient that we're all concerned about, and it's a patient that we're all trying to do right by. And that permanence and that peace of mind that we're giving the patient in reality, not as a marketing slogan or something like that, but the real benefit to being able to just redo these things at the drop of a dime, I think for me is the biggest element of it all.
Well, thank you, mate. It really is an exciting time. We have run out of time, unfortunately, and I thank you for giving us one reason, although you could have spent another half an hour on the rest of them. I love the fact that the carbon printers are doing everything for us here at RACE, and has put us in the same realm, as you mentioned here, with Adidas, Ford, NASA, and RACE Dental. That makes me proud. Yeah. But again, thank you all for joining us for episode 28, Dentures with Ease, and we look forward to seeing you all again next month for episode 29 of the RACE Academy webinar series. Come and see us at stand 566 at ADX and put those votes in for the Educational Initiative and the Innovation Award. Ian McFarlane, thank you for your time. We appreciate you once more.
All right, great. Thanks. Take care.
Bye, everyone. Thanks again. Be safe.